Hi guys, welcome back. This week's first adventure for Molly's Maths. It's 18th of January. Have you got your music on? I've got a bit of Morrissey on, I've got a bit of the Smiths. Listen to This Charming Man. Gets me in the mood for maths. Get your music on, get the right one for you, and let's move on to question one. Right, this is the old classic. Fractions, decimals, percentages. So we've got the values on the screen, and then we've got to get the values in each type of fraction, decimal, or percentage. So the first one we've got it in. We've got 7/100. Now we want to know. We've got it in a decimal, which is 0.07. Now 7/100 is, if we go to the percentage, it is the same as 7%. Sorry, the screen moved there a little bit there, so just move that up a bit. Oh, we don't want that line there, do we? Right, so that's the first one. So 7/100 is the same as 0.07 and 7%. So we've got the next one, we've got 0.35 and 35, and we need to find the fraction. Well, that's not too difficult. All we need to do is put 35 over 100. But we can simplify that, because how many fives in 35? So basically we got so you can, I'll do it at the side here, you've got 35 divided by 5 equals 7. So it'll be 7 over 100 divided by 5 equals, how many 5s in 100? 20. So basically the answer is, it's 7/20. Yeah, that's when we've simplified 35 over 100. So the bottom line, we got 3/5 as a fraction, we got 60% as a percentage, and we need to find the decimal. So the decimal really is, 60% is the same as 60/100. It's the same as so we'll write down here 60/100. So if you can imagine the decimal point being between the 1 and the 0, if it was a decimal, the decimal point above would be there between the. So basically, the answer would be 0.6. Yeah, so there we are. So that's the answers to that one. So I'm just going to tidy this up a bit, rub a bit of this out, make it a little bit more clearer. So basically, the answer is 35 over 100, and that will cancel down to 7/20. Just to make it a little bit more clearer for those that you can't see, but we did go through the working. Let's move on to question 2. Right, question 2, we've got a pattern on there, and it looks a bit like a snake on a graph, and the question is, we need to add one more shade, one more square in there to give it a rotational symmetry of 2. Now, anything with a rotational symmetry of 2 means that it can be turned around as if you're looking at looking like a flat bit of paper with maybe a hole in the middle of it, and you could spin it round and it would fit exactly again onto itself. So here, if we come over here and if we fill this square in here into a black, it's taking a bit of time. This I could do with a bigger pen. Morrissey's telling me that I should go out tonight because I haven't got a stitch to wear. How's your music going? So if we shade that in like that, and we stuck a pin in the middle, we could rotate that 180. So we could rotate that round like that, 180 degrees, which means basically just turn it, and the image would look exactly the same if we rotated it from a point right in the middle. And if we rotated it another 180, back, we would be back to where we started. So the order of symmetry for this would be 2, which is the answer to the question. So by shading that missing square in there, bottom, second one up from the bottom right, we create a rotational symmetry of 2 for the same image. I hope that's clear. Let's move on to the next question. Next question, plot these points on the graph. So we've got the graph there on the screen, and the graph is basically, we've got 2 sets of values. Along the bottom we've got job duration in hours. So if a company was to do a job and that took them so many hours, how much would they charge for that job? And so we've got a set of values down the bottom here, which are all along here. And the question, you need to plot those on the graph. And you can actually do that, or I've actually done it for you on the next page. As you can see, I've plotted the values on the graph. And so the first one, if the job took 1 hour, they would charge 60. They charged £60. Another job took 2 hours and they charged £80. 2 more jobs took 3 hours and there was £100 and 128, not 115, 100 and, oh, what was that value there? That was 108, 112 pounds. So as you can see, the longer the hours of the job, the more money they're making. And the question is here, describe the correlation of the scatter graph. Well, you've got 3 types of correlation for scatter graphs. You've got negative correlation, which means where one value goes up, the other value goes down. And then you've got a scatter graph that has no correlation, where we'd plot all the points on the graph and they'd be everywhere. They'd be all over the place. You wouldn't be able to see a sort of a line or a correlation. But this one, as each value goes up, as the duration of hours gets higher, they make more money on each job. So this is called a positive correlation because both values are going up. So I'm just going to write that down there. I'll write it down the bottom here. So this would be called a positive Yeah. Bit squashed down the bottom there, but the graph is a positive correlation because both values are increasing. The number of hours increases and the number they charge for the job increases. It's yeah, and you could. I hope you can see what's happening there. Let's move on to the next question. Right, this shape here. Can anybody guess what the shape is? That's right, it's a cylinder. And the question is, question 4, we need to calculate the volume of the cylinder. So we've got all the values on there. We've got the height of the cylinder, which is 10 centimetres, and we've got the radius of the centimetre. So let's just write, so I'm going to write that on there. So we've got the radius equals 4, and the height equals 10. And I've given you the formula here to calculate the volume. The volume equals pi r squared times the height. So if we substitute those values in, so volume equals pi r, which is times 4 squared, times the height, which is 10. So if we work through this in steps, V equals pi times, what's 4 times 4? 16 times 10. So if we go to the next step, you could do all of this on a calculator in one step, but I just thought I always like to sometimes put all the steps in. It sort of shows a bit of clarity. So 16 times 10 is going to be 160. And so we're down to the bottom now. So the answer is, if you do it on a calculator, you're going to end up with a value here of 503. And what is that? It's centimetres. But it's not just centimetres, and it's centimetres cubed because we're talking about volume. And the last thing we've done there, we've written that value down to 3 significant figures, which means only three figures, because with pi, when you multiply by pi, the value would go on and on and on for infinity, basically. So we have to round it up, and so we've done that to 3 significant figures. So I'll just put that in brackets underneath. 3 significant figures. There you go. So that's 503 centimetres square, that cylinder. Right. My pen went a bit crazy again then. Sorry, guys. Well, that's it. That's all the questions for today. Hope you've enjoyed it. It's been another good day for Molly's Maths, and I hope you can. Hope you're sort of really having a nice time in your music with your headphones, and we'll see you again soon. Goodbye.